Imagine you're sandwiched between two walls, both closing in on you from either side. That's the squeeze theorem for you, a fundamental concept in calculus that tells us how a function behaves when it's trapped between two others. For our first example, we're going to squeeze the function of sine of x divided by x between -1 over x and 1 over x, near x equals 0. As we move closer and closer to 0, both -1 over x and 1 over x converge towards 0. Now, the squeeze theorem tells us that if these two functions are converging towards the same point, then the function trapped between them, in this case sin of x divided by x, must also converge towards that same point. Hence, as x approaches 0, sine of x divided by x also approaches 0. Now, onto our second illustration of the squeeze theorem. Consider the function x squared times sine of 1 over x when x is not equal to 0, and 0 when x equals 0. We can easily sketch the graphs of -x squared and x squared, which serve as our lower and upper bounds respectively. It's clear that the function x squared times sine of 1 over x is trapped between these two. As x approaches 0, both the lower and upper bounds converge towards 0. Hence, by the squeeze theorem, x squared times sine of 1 over x must also converge towards 0 as x approaches 0. So, what did we learn from these two examples? The squeeze theorem is a powerful tool in calculus. It helps us understand the behavior of a function by comparing it with two others that we know more about. It tells us that if a function is trapped between two other functions, and if these two functions converge towards the same limit, then the squeezed function must also converge towards that same limit. These two examples demonstrated this concept beautifully. In the first one, we saw how sine of x divided by x was squeezed between -1 over x and 1 over x, and how it converged towards 0 as x approached 0. In the second example, we saw how x squared times sine of 1 over x was trapped between -x squared and x squared, and how it too converged towards 0 as x approached 0. The squeeze theorem, ladies and gentlemen, is a testament to the beauty and elegance of mathematics. It's a simple yet powerful theorem, and it's just one of the many examples of how mathematics can help us make sense of the world around us.